What if one day the sky started bending? Not exploding, not burning, just warping. The stars twist, the moon stretches, and before anyone can explain it, Earth is already falling. Not into fire, not into darkness, but into something that doesn't let anything escape. A black hole. And once you're close enough, there's no impact, no explosion, just you being stretched into nothing. There are millions of black holes scattered across the Milky Way. Most are far away, harmless, distant remnants of massive stars that died long ago. But this one is different. This one is close, too close. Whether it's a wandering stellar black hole or something far worse, a supermassive one like Sagittarius A, the result is the same. Earth has been caught in its gravity. You wouldn't see it, coming directly. Black holes don't shine. They don't reflect light, but you'd see what they do to everything around. Them. Stars would bend, stretch, and warp as their light curves around an invisible center. The night sky would twist into something unrecognizable. And then, slowly, Earth begins to drift. Not by choice, by force. Every black hole has a boundary, a limit beyond which escape is impossible. It's called the event horizon. Once you cross it, nothing comes back, not even light. At first, Earth is still outside this boundary. There's still a chance, however slim, to escape. But the closer we get, the stronger the pull becomes. Gravity isn't equal anymore. It's uneven. The side of Earth closest to the black hole feels a stronger pull than the far side. And that's where things begin to fall apart. The oceans respond first. Water shifts, rising into massive bulges facing the black hole. Tides unlike anything in Earth's history surge across the globe. Entire coastlines vanish beneath. Then the atmosphere begins to go. Air is pulled away, streaming into space in long, invisible tendrils. The sky thins, pressure drops, and beneath your feet, the ground starts to move. The uneven gravitational pull begins to stretch the planet itself. This isn't just earthquakes. This is planetary deformation. Continents crack. This process creates intense internal friction, heating the planet from within. It's called tidal heating, and it turns Earth into a furnace. Volcanoes erupt everywhere. Lava floods the surface. Ash clouds choke the sky. Tsunamis crash into already fractured land masses. Earth isn't just being pulled apart, it's being cooked. If Earth doesn't fall in immediately, there's a brief, horrifying possibility. It gets caught in orbit. Each pass around the black hole stretches and compresses the planet again and again. The constant deformation generates more heat, more destruction. The surface becomes unrecognizable, a molten, fractured shell barely holding together. There is no recovery, no rebuilding, just survival from one moment to the next. But Earth isn't alone. The Sun and the rest of the solar system are also caught in this gravitational nightmare. The delicate balance that keeps planets in orbit begins to fail. Orbits shift unpredictably. Planets drift, collide. Mercury and Venus might spiral into the Sun. Mars could be ejected entirely. And then there's the asteroid belt. Hundreds of thousands of rocks, some over 100 kilometers wide, are destabilized. Many are sent hurtling inward, toward Earth. If one of those impacts us, it wouldn't matter what the black hole does next. It forms a swirling disk around it, an accretion disk. This disk becomes one of the most violent environments in the universe. Matter accelerates to incredible speeds, colliding and heating up until it emits massive amounts of radiation, X-rays, gamma rays, energy that can tear atoms apart. Even if Earth somehow avoided destruction from gravity or impacts, this radiation would sterilize the planet. There is no safe distance anymore. Everything, is hostile. Everything is lethal. Eventually, Earth gets too close. There's no sudden explosion, no cinematic collision, no moment where everything ends in a flash. Instead, it begins slowly. Then, it becomes unstoppable. This is the moment when gravity stops behaving like something familiar and becomes something far more terrifying. This effect has a name: spaghettification. For a human, this would mean your feet feel weaker, your body stretches, pulled apart along its length, thinning into something unrecognizable. But Earth is not a human. It's a planet. And for a planet, the consequences are catastrophic. The side of Earth closest to the black hole begins to accelerate faster than the rest. The crust fractures first, massive cracks ripping across continents. Oceans surge and tear free, pulled forward into space like threads unraveling from fabric. Then the mantle follows, then the core. Earth doesn't shatter all at once. It stretches, slowly at first, then faster, then violently. The entire planet elongates into a glowing stream of molten rock, metal, and debris. What was once a sphere becomes a line, a long, thin, incandescent strand. This is the final transformation, the moment Earth stops being a planet and becomes matter in motion. At some point, what remains of Earth crosses a boundary, an invisible edge in space, the event horizon. From the outside, this is the point of no return. Anything that crosses it would need to travel faster than light to escape, and nothing can do that. From the inside, we don't know. And that's what makes it so unsettling. Inside a black hole, the rules of physics begin to collapse. Gravity no longer behaves the way we understand it. Space and time, once stable, predictable, become warped into something entirely different. Distances lose meaning, directions blur. Cause and effect may not behave the way they should. If a black hole were detected far enough away, there might be time to respond. Humanity could attempt to build massive spacecraft, generation ships designed to carry people far beyond the reach of danger. We could try to leave Earth behind, but even that plan is filled with problems. The gravitational pull of a nearby black hole wouldn't just affect Earth. It would disrupt the entire solar system. Asteroids would be flung into chaotic trajectories. Radiation from the accretion disk would flood space with deadly energy. Navigation would become nearly impossible. Safe routes wouldn't exist. Every direction would carry risk. Black holes don't just destroy, they erase. Not in an instant, but completely. They don't leave ruins behind. They don't scatter remains across space. They take everything, every atom, every structure, every trace, and pull it into something we cannot see or understand. Planets disappear. Stars vanish. Entire systems collapse, and with them, everything that ever existed there. Every history, every moment, every life, gone. In the end, it doesn't matter how advanced we are. It doesn't matter how much we learn, how far we travel, or how powerful our technology becomes. Because when something like this comes close enough, there is no defense, no escape plan. That guarantees survival. No version of events where everything turns out okay. There are only outcomes, different timelines, different endings, but they all lead to the same conclusion. When a black hole arrives, there is no winning, only different ways to lose. And yet, one mystery remains. What really happens inside a black hole? Do we disappear forever? Or do we end up somewhere else entirely? Because the truth is, we've never seen the unbelievable stories hidden in the fossil record. Subscribe Edge of Reality.